Once again, warm welcome to all the viewers of this channel. So this is Ritwik. Today we are going to see some of the aspects of BFS and DFS in detail. As far as AI is concerned, this BFS and DFS is going to play a major role. In the current scenario, we are going to see the real-time applications as far as BFS and DFS is concerned. So BFS is breadth first search and DFS is depth first search. These two searches are going to play a major role as far as artificial intelligence and other domains are concerned. So today we are going to have a brief look regarding the BFS and DFS and other impacts of BFS and DFS. So coming to the basic thing, we have two important search strategies. One is uninformed search strategy. Another one is informed search strategy. So coming to the uninformed search strategy, we do not have any sort of information regarding it. So the major goal of artificial intelligence is we have some sort of agents, and agent should reach a particular goal. So how it takes place, it is the matter of using the various mechanisms of data structures to reach the particular goal. So how well you are going to train the agent to reach the goal, that matters as far as whatever might be the search strategies are concerned. So coming to the AI part, the basic part, we have uninformed search strategy and informed search strategies. These two are the two important search strategies. In the uninformed search strategies, we do not have any sort of information regarding the number of steps. You have a agent and you have particular goal. You need to reach to that particular goal. How well you are trained to reach that particular goal is of matter as far as uninformed search strategy is concerned. You have the goal state and you have the agents along with you, but how well you are trained in such a way that your agent is going to reach the goal, that is the primary question or the matter that concerns. So this is the major thing as far as AI is concerned. So now coming to the basic mechanisms of AI in the uninformed search strategies, we need to go in a blind direction. We do not have any sort of routes or paths. It's like traveling on the road with a light, but we do not have a light, but we need to travel on the road in the night. So that is the major thing as far as uninformed search strategy is concerned. So we need to measure the path cost for reaching the goal to the final state, from the current state to the final goal state. That is one of the major key concepts. And we need to search it in a blind manner. So that is one of the key important aspects. Now coming to the informed search strategies, we are having some sort of relationships as far as the goal state is concerned. We have all the information regarding the states to reach the goal. For suppose you need to travel from your home to the complex or any other stop. You know the directions. If you know the directions, it comes under informed search strategies. You do not know the route, but you need to travel along with that particular direction to reach your goal state. That deals with the uninformed search strategies. So majorly, we generally use the maps, right, to travel from one state to the other state. So these maps consist of the uninformed search strategies. But informed search strategies, we have all the clear-cut mechanisms as far as reaching to the goal state and all the mechanisms we are having. And based on the mechanisms, we are going to reach to that particular goal state. And how well and how well you are trying to reach to the goal state, it is going to matter much. Now, based on the information of the current state, you are going to travel to that particular direction or the location. So, what are the basic uninformed search strategies? We are having uniform cost search. We have breadth first search. Now, in this session, we are going to deal with the breadth first search area. And what are the other aspects, other things? We have depth first search. These two are the two important search strategies as far as uninformed search strategies are concerned. Now in this, we have some subparts, which is called as uniform cost search. We have depth limited search. We have iterative deepening search. We have bidirectional search. These are the other search mechanisms as far as problem state space is concerned. Now, before you go through all the search strategies, the primary thing you need to define is the problem. how you are going to align your domain problem to the state space. That is going to matter as far as AI is concerned. So the mechanism that uses in the AI is the automation. You all aware of it. I am not going in detail regarding that particular mechanism. So to reach the goal, what are your mechanisms? That should be in your mindset. Suppose you are developing a website. In the website, you need to navigate to each and every state. So how well you are going to train to reach to the each and every page in that particular web page, and how you are aligning all the page to the home page. It is also a matter. So how you are going to define the state space of a particular problem. Based on the state space, you need to define all the strategies according to the time periods or the time bounds. Now coming to the basic two aspects, that is the breadth first search and depth first search. In the breadth first search, we are going to have the location of the FIFO, so which is called as first in first out order. And based on the nodes, based on the first in first out of the nodes from the root node, you are going to expanding all the other nodes. So this is also one of the major criteria as far as if you learn any sort of data structures and other related concepts, you can have a good idea regarding the breadth first search. So now coming to the breadth first search, we have the root node. Starting from the root node, you are going to navigate all the other nodes. Suppose A is the node here. From A, you are going to expanding B and C. Now after expanding B and C, you are going to expanding all the nodes of B, D, E, F, and G. You are going to expanding all the other nodes after expanding the root node. So that is the thing that happens. Suppose this is the example. You need to start from S to A to D, and D after you need to expand B and D, and you need to expand A and E accordingly. And now you need to travel forward, and then you need to expand C and E and B and other things. Likewise, you need to go through. Suppose this is the example. You are going to expand first 1, and after 1, you are going to expand 2 and 3. And after 2 and 3, you are going to expand the other nodes 4, 5, and 6, 7. Let us just see with a sample example regarding the breadth first search. Suppose this is a college. In the college, you need to travel to the final destination point. So these are the various blocks of the college. This is the chemical block. This is the civil block. This is mechanical block. This is canteen. This is IT block. This is CSE block. This is ECE block. This is EEE block. And this is first year block. So all the blocks are there. You are having all the blocks. The first thing that you are going to do as far as you come to the college is that you are going to travel from the civil block to the CSE block. And beside the CSE block, you have admin block. Based on the localities or the current mechanisms, you are traveling to the admin block based on your needs. Suppose let us just consider you need to travel from the civil block to the CSE block. How you are going to travel in the first search? We can see with a small example. So from the civil block, you are traveling to the chemical block, and after chemical block, you need to move forward to the first year block. And after moving to the first year block, you need to travel to the mechanical block. And after moving mechanical block, you need to travel to the EEE block. And after moving EEE block, you need to travel to the canteen block. And after moving canteen block, you need to travel to the ECE block. And after moving ECE block, you need to travel to the IT block. And after IT block, you need to travel to the CSE. So if CSE block is your destination location, you need to travel all the blocks. You need to cover all the parts of the college to reach to the CSE block as far as breadth first search concept is concerned. Because here it is the root node, civil block is the root node, and we are traveling with the agent. And our goal is to reach to the CSE block. From the civil block, you need to travel all the way from the chemical block to the mechanical block and first year block and EEE block and canteen block and EC block and IT block. From there, you need to travel to the CSE block. So this is a collaborative cycle as far as BFS is concerned. Now coming to the other strategy, the basic things or the analysis of this BFS is that whether it is complete. you are going to cover the entire college in the BFS location. So we can say BFS is complete. We can complete the entire thing. We can have the completeness of the entire graph. We are going to cover each and every node of the graph so that we are going to move to the final destination. Now coming to the time bound, this is the major constraint. So how much time it conserves as far as you move from the civil block to the CSC block? It takes a lot of time and a lot of effort is going to put as far as reaching from the civil block to the CSC block, covering all the localities. So this is the major challenging task as far as BFS is concerned. So we have the completeness, but we have the time related aspects of the time related cost. So we cannot say that it is identical to use the time. We have too much of time, we have too much of space. This can be shown as an example. You can have some sort of examples like this. While traveling, you need to calculate the entire time and how much space you have consumed regarding that particular time period is concerned. So you may have a question that how to calculate the space. The number of steps you move that deserves the space complexity. And how much time you can have the time period. You can put some 10 to 15 minutes of time and based on the time period, you can have the movements from the civil block to the CSC block. That is the second thing. And this is the most important thing, that is optimal. So whether this is optimal or not, we can say that it is optimal because we are traveling only one step forward. We are going to navigate all the nodes with one step ahead. But the main issue is the time and space. We are consuming more time and space. Because of the completeness, we need to cover all the entire. So when you are going to build some sort of solutions as far as problems are concerned, you need to have the mechanism of the time period along with the space period. Both are to be mapped with each other. Time and space. We need to make a measurement regarding these two things. So how much time you are going to consuming and how much space you are going to take. We need to have less time and less space. So because any sort of interventions, if you are doing in AI, so we need to consume the less space and less time. Based on that only, you need to have the recovery of the other elements. So these are the some of the time periods, some of the depths and other aspects. So these are the some of the times around 3000 if 10 power 15. If you are traveling 14 nodes, it is going to take 10 power 15. You are going to consume more time around years. 3.5 to 3 years around you are going to consuming and you need to have one extra byte for every each and every time. So terabyte, after terabyte also you are going to increasing the hexabyte based on the time period. You are having more amount of time period as far as this is concerned. If you have 1,000 nodes or 10,000 nodes to solve the nodes, it is going to take much. Now coming to the depth first search, the other aspect of the search. So in this, you are going to expand all the deepest nodes first. And then you are going to the end node. From the end node, you are going to travel all the leaf nodes, but you are not going to touch the goal. So your goal is touched at the end of the session. Suppose A, B, C, D, and E are there. You want to move from A to you need to travel to the G node. So you are traveling B first, and after you are traveling B, you are going to expanding B and E, and now you are going to expand C node and F node, and later on you are going to travel to the final node. You are going to first deeper into the C and touching the node. So if your node is G, in this expansion, in this couple expansion, if you find the node G, it is good. If you do not find the node G, you need to travel to the other side of the coin and traverse all the nodes. So it is also going to consume much time. So while traveling from the node to that particular location, you are going to move. So let's just take the same example from the civil block to the CSC block. How you are going to travel? How much time you are going to consume in the depth first search? First thing is that you are going to expand all the nodes from the root node to the final destination. So from the CSC block, I'll go to the first year block and EC triple block and EC block, and now I am moving to the CSC block. So this is the entire cycle. If I got the CSC block in this cycle, the cycle is set to be complete. I will not traverse the next side of the graph. If I do not find the CSC block, now I need to move to the chemical block, mechanical block, canteen block, IT block, and then I will move to the CS block. So in this, I am going to cover all the entire cycle. So these two are the two important aspects. Now, coming to the analysis, whether you are going to complete, if you have found CSC block over here in this particular graph, you should not traverse the other side of the graph. So it doesn't have any sort of coverage. If you do not found the goal state in that particular traversal by dipping into the sea, now it is the time you need to cover the entire graph. So it's like an ocean. In the ocean, you have depth and width. So you have the depth and width. You need to know the depth and you need to know the width. So in the width form, you can have the BFS, and in depth form, you can have the DFS. So both are important to travel into the sea. So if you do not know the depth, you cannot travel over the sea. If you do not know the width, you cannot travel to reach your particular destination or location in the sea. So both are important. So whether it is optimal, it is not optimal because we cannot have the best solution. So how it overcomes? You can have less time and space as far as depth first search is concerned. So complete, it is not complete. Time period is somewhat better when compared to the breadth first search. You can have the solutions in a better way. Space, you can have some less space. Optimal, you cannot have the concept of optimality. And coming to the other aspects, you don't have all those things as far as breadth first search and depth first search are concerned. So these two are the major important concepts as far as AI is concerned. So let us just go through the other aspects in the future classes in the upcoming years. So I hope you all have learned some of the things as far as AI is concerned. Thank you for watching this video.